Hello you beautiful internet people and welcome back to another video. So yeah, I bought another word processor. So a while back I asked you guys if you would like to see more like logic based redstone, and like if I'm correct, like 75% of you voted for more logic based redstone. So you're getting more logic based redstone. Don't worry, I'm not getting rid of the normal redstone, just I'm going to be doing few of these things as well. But as you can imagine, they take considerably longer, so yeah, just hold on. So if you're kind of confused, this basically is a Minecraft word processor, version number 2, for me at least. And basically what it does is it's basically Microsoft Word, but in Minecraft. Now, I did this a couple months back, but it was absolutely rubbish in comparison to this thing. It had that weird segment display, so it looked like a glorified microwave, and each like display style had its own separate ROM. It didn't have centralized ROM like this one, so it was kind of slow and very laggy, and yeah, just not very good overall. And it only had a combination of of uppercase and lowercase letters as well as 0 to 9, but you couldn't choose like if you would like to an uppercase or the lowercase. But with this sucker, we have all of the digits. So this is our ROM over here, and we have one for uppercases, we have one for lower cases, and then you might be confused because why the number one is just as long, and that's why this one does not only have the letters and the numbers, it also has 16 symbols. So if we move over to our input over here, you can see all of the different stuff that we have here. So obviously here we have all of the like letters with the caps lock obviously. Here we have the numbers, and here are all of the symbols that are supported on this thing. Now, the thing that makes this probably a million times better than the other one is these four buttons down here. So you can choose if you want to type on the top or on the bottom. You can choose to go left and right. And you can even go back and delete or change out things that you have typed in the past. So let me give you a quick example. So the, do take note that I'll try and zoom in on this thing, but the sad thing about Minecraft Bedrock is instead of dropping frames, it instead opts for like dropping like mob AI and like redstone. So even though my frames are not laggy, you'll see the redstone is incredibly laggy. Like it takes about 3 times as long for a piston to extend. But let's type, well, we type T on the other one. So let's type T as well as a comparison. So we have the T, and if we can just see how long that piston took to extend, it just takes an absolutely crazy amount of time to do thanks to the way that Bedrock is optimized. But we can go for the E, and if we just wait for this thing to work, there we go. And can we do A? Yes, we can do A. Hopefully that wasn't too soon. Maybe I should put like an indicator in here. But don't worry, we'll get to the redstone in a moment. But oh, we want this first one is in lower cases. We wanted to use an uppercase, so we flip caps lock, and now we go left by 2. So one click and it will be move 1 back. If you just give it some time, as you can see that person there, that's a good indication of how slow the redstone is actually functioning. Like that thing isn't even properly like rendering everything in. Okay, and for the final time, left once again. Come on. Okay, so now that we are on the T, we can do one of two things. We can either delete it for an empty space over there, or we can just straight up replace it with something else. So we already turned on the caps lock, so let's put in a capital T instead, and we will switch over to the capital ROM module, and that T will be replaced with the capital T, and now you just have to, it will move automatically to the next slot. And if you want to write something underneath it, we can flip this lever over here to use the bottom section, and we will see in a moment that indicator jumping down to the bottom set of displays. Ah, okay, so this thing might not be finished after all. If just quickly fix this, quick and dirty. Okay, now we'll see that it goes down to the bottom a lot faster, yeah. And we can go back up and then go down again. Now, like I was busy saying, the most the most obvious thing that changed in this design is we don't have that 9 segment display modules anymore. We have a more we have a matrix display which looks a lot better in my opinion, because it looks like a genuine screen instead of just randomly having, what do you call it? Uh, Instead of having random, like it's hard to read the segment display. This reads a lot better. And obviously, like I mentioned, this one also has symbols because we can display more things at once. Where are the colons? Yeah. Look, we can even make a little smiley face if we want to. Oh no. Okay, so let's get into the reason behind this thing, because as you can see, it's pretty big. Now, off the bat, this orange, blue, and these couple of lines, they're just the input. So they go from this input panel over here, and they just carry it to where it needs to go. Now for the actual redstone. Basically, how I ended up building this thing was I watched a video by Crafty Masterman about a working etch-a-sketch that he made in Minecraft on the Java, obviously. And I saw this one component which will allow you to move forwards and backwards on a display. And I thought, hey, that's pretty nifty. Maybe I should try and do that. And I did. But you see, despite what people think, even logic redstone is different on Bedrock. So here was the design. You see these repeaters with pistons? Just imagine them on both sides. And that was the system that worked. But thanks to Bedrock, these redstone actually depower instantly when that repeater is depowered, which results in only this side functioning for reasons I'm not entirely sure, or like I am sure that's probably what it is. Like as you can see, I had to make a modified version of it so that I could actually get it to work. But this thing is kind of huge, even though it's not kind of huge. I designed this with the idea of it only being 2 wide per module, because at the time I thought I was going to have one of these for every single pixel. So that gave me 3 more opportunities to design a new one. After this failed, I went for this design, which I came up with on my own instead of trying to modify an existing one. And it basically how it works is we have, if we just power this thing, this repeater will constantly be powered because it's in a loop. And basically, when we extend this piston, this loop will get cut off. And we basically have an AND gate over here. So the bottom observer will detect that, in fact, this dropper is powered or depowered, and that this block has moved. And if both of those things happened, then only this torch will turn off, powering the next one. So if for instance, we do not have a block there and we try to move it to the next cell, you can see it won't move to the next cell. But if we place a block there, it moves to the next cell. But like I said, this one also uses observers, and observers are kind of unreliable on Bedrock, in my experience at least. So that's why when I made this design, an observerless design, and it also worked pretty fine. The only problem with it I discovered later down the line. So I, as you can see, I used that repeater system that I talked about earlier in this one combined with my own one, because I thought maybe I'd get the best of both worlds. But the problem was, once again, Bedrock Redstone is weird, and so you don't have instant wires or anything like that. And so as soon as you added a repeater and these pistons extended like one tick later than these ones, the system broke. So for the fourth time, I had to design another one, and that's when I came up with this thing. Now this is the final design that I ended up using. I think I may have compacted it a little bit by just moving like it one back, but as you can see, it works flawlessly. We can move backwards and forwards. Now it works off of the same concept as this first design, basically utilizing AND gates. So as you can see, we have this constantly powered circuit over here. As soon as this piston extends, it will cut off this infinitely powered system, which will activate this torch, which will activate this line. But this torch will be deactivated for a split second, which will, for like what's this, for 3 ticks, which will turn off this torch, which will turn on this torch for about 3 ticks, powering the next module. But should this one already be depowered like that, this torch will already be on, and so even when you extend a piston over there, it won't move to the next cell. So this is the system that I use to move forwards and backwards on the machine. Now, the pixels that I used isn't actually designed by myself. I can't remember where I saw it, probably on like Reddit or somewhere, but they're pretty simple to build and they can be stacked on top of one another. Now, as you can see, they are 2 by 2 big because that's a lot easier to work with than just one. And one of these cells is a pixel. So if you want to like copy it from here, they're pretty simple to build and easy to replicate. And now this thing is one of the ROM modules, but we can see it better working in action with the rest of the ROMs and the rest of the word processor. Now I have to say this thing looks actually pretty cool when you fly in from like distance. But as you can see, we have three of those ROM modules over here. One for the uppercase letters, one for lower cases, and one for numbers and symbols. Now they're actually pretty simple to do. All that they are a bunch of lines with redstone with torches. So we just have all of these lines, and these green and white lines each correspond to a cell on the X and the Y axis inside of, I like to call it a character. Now, a character is a 5 by 5 pixel area where all of the letters fits in. And yeah, so each of that's why our ROMs are also 5 by 5 because each cell is 5 by 5. And over here, we convert those 5 by 5s into an output for all of the cells. But we'll get to that later on. So how these guys work is we have obviously all of these lines, and these torches are actually the stored memory. So if we were to power this torch, this also, all of these powered redstone would deactivate, turning on these redstone torches. And these redstone torches will power these lines, and like I said, they lead into the pixels. And basically, all that these this white circuit is, it basically combines the five modules into one output over here. And they needed to have a little bit of a delay to work properly with some of the other features, but I actually at the moment I can't remember exactly what. I think it's the clearing mechanism. Now, you might be wondering just exactly how do we switch from this ROM to this ROM to this ROM? And well, the answer is pretty simple. To switch from letters to symbols and numbers, we just have a second row of inputs here because they have their own buttons. But for the letters, it's a bit more complicated than that because I really wanted to only have one set of inputs for both capital and lowercase letters. And so how I achieved that was with this tiny blue circuit over here. So from here to about here. And basically how it works is we receive an input from this line, and this line will power both this rating line over here and this bottom one. Now, should we power this purple circuit over here real quickly, we will see that the all of that those pistons as well as these pistons extend. Now this redstone will be able to power this repeater, which will activate this first one, whereas at the bottom that block gets moved out of the way, preventing this repeater from being powered. And when we depower it again, these pistons retract, allowing the signal to pass through that block, but these pistons also retract, preventing the signal from traveling through those blocks. And then it's just a simple process of connecting it up to the input on the ROM itself. Now, for the next line, the I wonder what I should do first. Okay, let's do the gray and the red. Now, they might seem simple, but it actually took me a while to come up with this design. And basically, it's the reverse of that ROM, basically. So we get a signal running into this gray circuit over here, and this gray circuit will actually continue power giving out a signal. Let's say you type A, then it will send an A input into all of the character cells. Like should have probably said it earlier, but what I mean by character cells are those 5 by 5 pixels. Now, as you can see, all of these character cells will get powered. And then later on, we decide which one should actually give an output on the screen itself. Now, the red circuit is pretty simple. It just it takes an output from the gray and runs it into the pixel in the end, essentially. But as you can see, it runs it into this. It's not a T flip-flop, but I actually don't know what you call it. But basically, it's a T flip-flop, except you have two different inputs. So the red will power this dropper over here, which will split the item into this dropper, giving out an output. And then we later on power all of these droppers, which will shoot the items back into this dropper, and thus turning off the lamps. Now, if you're curious why I used raw and concrete, the raw is just for me to see like where each character cell ends and starts. Now, because it's why am I saying now so much? But anyway, at the back here, you can see that what I basically did was actually quick and dirty to get it to work on the top and the bottom layer. So the original input was only on the bottom layer, as you can see here. So what I ended up doing was to hijack the output from the bottom over here and transfer it all the way through that circuit into the top. And as you can see, it's a bit wide because each like line on the height is moved a bit more to the side so that I don't end up overlapping them as much because yeah, as you can see here, it just looks kind of like a mess and it's kind of difficult to work with. Now, now we can come to the selection phase. So how do we select which cell to power? Now, this black line is responsible for choosing where it lies on the y-axis. So should it be the top line or should it be the bottom line? And how it works, through a lot of fine-tuning of timings and everything, it basically just comes down to the same system that I used for choosing between the uppercase and the lowercase symbols or letters. So as you can see, currently the bottom layer is selected. So we moved all of the blocks out of the way. So if we should receive an input, the input would end here because we won't be able to power this redstone. Should this be depowered, you can see we have the blocks in the right position, which will allow this top circuit to be powered. Now, depowering the bottom circuit was a bit more of a pain, and that's why I ended up having to do at the top here as well. Now, that's simple enough, but here is the problem. How do how do I prevent it from powering the bottom? Like, it's simple to choose between the top to activate the top as well or only the bottom. But what if I want to activate just the top? For that, I needed to deactivate this bottom circuit. Oh, in case you're wondering, this light gray circuit is that blue circuit, or is that sine circuit that I showed earlier in the video. So as you can see, it's just a bit extended out here to line up correctly. But it's literally exactly the same. I only dropped these pistons horizontally instead of vertical to make it a bit flatter. But essentially, back to the black circuit, what I ended up doing was to power all of these pistons. Now, you saw them when I talked about the red circuit, and basically, they move the glass in front of the repeater when it should not be powered, and they move the concrete back in front of the repeater if it should be powered. So as you can see, all of these are currently depowered. So if we quickly go and find the current active one, we should see that its pistons should actually be retracted. Yeah, as you can see, this cell is selected, so all of its pistons is retracted. So if we would send an input through this block, it would successfully activate this T flip-flop thingy over here. Now, how this black circuit works over here, if I can find it again. Yeah, there was a pain to build without spectator mode, but anyway, what this black circuit will do if the top one is selected is it will power all of these pistons regardless of whether they should be powered or not should not be powered. So as you can see, if this line would be on, then this resin would also be on even though it is powered. But the way that I got this one to select a x-axis module both on the bottom and on the top was to hijack this signal and run it up here into the onto the top layer like that, and that caused a lot of problems because when I would power these bottom pistons, then these pistons would be powered as well, preventing the signal from being inputted from the top and the bottom. So that's where this little delay in the beginning comes in. What I would do is power all of these top pistons before powering the bottom pistons. And basically all that does is obviously when a piston is powered, it can't be pushed, and thus we fixed that problem. Now, it was actually a pain to come up with that. I'm kind of sad that I didn't come up with that earlier. But as you can see, if you were to power this piston, then it would obviously not move, and thus we would end up with an input over here. I, I have an idea I'm not doing too good of an explanation. I'm sorry, okay? I'm not really good at explaining stuff. But anyway, that's how we are able to move the little line thingy from place to place. Now, you might be wondering what this awful looking magenta circuit is doing, and it's caused me just as much problem as this little black circuit, because basically it's responsible for going back and editing the circuit like or the output like we did with that T. So when I changed the lowercase t to the uppercase T, I had to first delete the lowercase t before being able to give an input for the uppercase T. And this little magenta circuit handles that just fine. So it works pretty much, it takes an input from the gray circuit that's responsible for selecting an output. And if we quickly flip to the top layer, you can see it in action. So now that the top is selected, you should see that this piston over here will be extended, whereas all of the other pistons will not be extended. So if we power this magenta circuit, it will activate the deleter module on this one character cell, but because all of these blocks are moved out of the way, it won't affect the rest, just this specific one. And that leads nicely into the next circuit, which is the yellow circuit, aka the resetter. Now, it's actually, yeah, I had to rebuild it about 3 times because I had to constantly change it. So how it works to reset a cell is basically we have to run a line across like this on each of these like lines like that. And it was a bit of a problem because as you can see, they're really close to one another. And I obviously don't want to power these ones. I only want to power these ones, but I don't want to put a crazy amount of repeaters in. And now I also have to somehow stop it from powering all of them if I only select one cell. And that's why I had to end up using observers over here. Otherwise, it would have been a completely observer-free system. But basically, what it will do is power that block over there. Because as you can see in its current state, it will pull the redstone circuit or the redstone line to lie like that instead of being a dot. And when it will be powered in that state, it won't actually power this repeater. But if if it's a dot like that, if it's oh, I might have just broken it. But if it's a dot like that, it will actually power it, and hopefully that didn't really break the system too much. I'm hoping, yeah, we lost part of the T, but I mean that's not too much of a problem. Now, if you're wondering why I didn't just simply do that, that was the original idea, but by lying a redstone line on this dropper, it would power that dropper as well because yeah, that's how redstone works. And that is pretty much it. Now the top circuit and the bottom circuit are similar, but they're not the same. So as you can see, the magenta line over here, that is pretty much the same, but the what did I call it? Uh, where is it? What which line was it? Was it the black? Yeah, the black circuit is different, and the cyan, yes, the cyan circuit. I think it's the cyan circuit. This was also a bit of a pain to make. Now, the cyan circuit is responsible for displaying this low line, which will show your selection. I almost forgot about it. And it was a bit of a, it's, as you can see, it's a pretty simple circuit, but getting the input was what was the problem. So at the bottom, it was really easy, and I'm building up a slight cough over here. But anyway, as you can see, all that we simply did was we stole an output from one of these, which will show the selected cell. But for the top circuit, it was a bit more complicated than that because we couldn't just simply steal a sign from output from the side over here because of the way that our vertical selector worked. And that's why I had to install these separate rows of random blocks over here. If you can fly up these blocks. Now they are pretty much of those blocks, these cyan blocks. Now they're pretty much the same than these one. Like, they're just this way to move a signal that they get from up here all the way down here to the actual selector. So if we quickly fly over to the selected one, as you can see, it's selected, which means this piston is extended, which means this redstone line gets powered and these lights will power on. And if the top is not selected, we simply extend some pistons which will cut off those outputs, and thus there will be no display on the top. And that is basically it. Hopefully it made sense. Oh yeah, I wanted to say one last thing. As you can see, we have some more magenta circuit over here, and that's just to get an input so that it knows that you're replacing it's connected up to the ROM so that it knows when you are sending a next input so that it can delete the previous output. But okay, let me rephrase. So when we move the cursor, we obviously don't want it to straight up delete the characters. So what I instead did was delete the character as soon as a second output was received on that specific cell, and that's basically what the magenta circuit does. Hopefully that makes sense. But yeah, My throat's incredibly dry from all of that talking, but yeah, hopefully you guys enjoyed. And feel free to leave a like and to subscribe if you're new around here. And I also have the social medias on Twitter and Instagram if you want to go check that out. But thanks for watching, guys, and I will see all of you again in the future with a brand new video. Bye!